Let's start with the question number 21 then, right? Okay. This is the question number 21 with the past paper MCQs, right? In your analytics workbook, right? Question 21. See what it says. 21. See. A reaction is spontaneous at 298 Kelvin and 100 kilopascals pressure, while it is non-spontaneous at high temperature and the same pressure. Which of the following is true for these reactions at 298 Kelvin and 100 kilopascals pressure, right? Okay, first discuss what the data given. So at 298 Kelvin, 10 kilopascal pressure, non-spontaneous at high temperature. Okay, yeah. So they are saying spontaneous at 298 Kelvin and higher temperatures non-spontaneous. So non-spontaneous at temperatures above 298, or one can say higher temperatures. Let's say higher temperatures. At higher temperatures, non-spontaneous. At 290 is spontaneous. That means your delta G, the spontaneity or the delta G, the sign of delta G will depend on temperature. That is what it means, no? Right? Spontaneous means delta G is negative. Non-spontaneous is delta G is positive. So the sign of delta G depends on the temperature. Right? That is what it means, right? So if you think of the delta G and the delta H minus T delta S, right? That is what delta G means. The delta G will depend on the temperature. That is what it says, right? Delta G will depend on the temperature, right? So it could be negative or positive. Depends on the temperature, right? So how it is possible? How it is possible? How that kind of thing is possible, right? For the possibility of such a sign for delta G appears when the signs of these two are right not the same. If this is positive and this is negative, this kind of a thing would appear. When this negative value is greater than this value, the sign will be negative, and if the negative value is smaller than this value, the sign will be positive. If the signs are like this kind of scenario could appear. Or if the signs are like this, basically if the signs are with two opposite signs here and here, this kind of scenario could happen. With higher positive value, this positive will be the delta G signs, right? If with a lower positive value, delta G could be negative, right? So we have two options, right? So what they are saying, they say at higher temperatures non-spontaneous, at higher temperatures non-spontaneous, at higher temperatures non-spontaneous, right? So what is that idea? Right? That idea means, right, basically the sign here, the value here, the value with this sign will be affected by the temperature effect, right? By increasing or decreasing temperature. Nothing happens to this thing, right? They are saying with higher temperatures, the thing will be non-spontaneous. With higher temperatures, the value of this thing will be high. They are saying with higher temperatures, the thing is non-spontaneous. Higher temperatures. That means to have a positive value here with higher temperatures, this should be positive. and then this should be negative. Right නේද? So higher temperatures එක ළමයි මෙතන තියෙන sign එකේ value එක තමයි වැඩි වෙන්නේ. Temperature is affected by temperature is affected only to the value of this sign. The sign at here, not the sign at here. Right නේද? එහෙනම් higher temperature එකදී non spontaneous වෙන්න නම් අනිවාර්යෙන් higher temperature එකදී වැඩි වෙන්නේ මෙතන තියෙන sign එකත් එක්ක තියෙන value එක. එහෙනම් මෙතන තියෙන sign එක positive වෙන්න ඕන. So that is going to be negative. හරි අනිවාර්යෙන් signs දෙක opposite signs තියෙන්න ඕනේ. මම කලින් ඉගෙන කතා කරා. Right? එහෙනම් ඔය වගේ situation එකක් තියෙන්න ඕනේ. ඒ කියන්නේ at higher temperatures, right? This should be positive. The positive value should be greater. Right? Higher temperatures. High temperatures. Not spontaneous. Right? Alright. And එහෙම වෙන්නේ නම් ළමයි මේක positive වෙන්න නම් as you have a minus sign here, this should be also minus. මේ මෙතන minus sign එකක් තියා මේක positive වෙන්න නම් this should be also minus. Minus to minus will give you a positive value. හරි. ඒ කොහොමද signs ටික consider වෙන්න ඕනේ. ඒගොල්ලෝ අහන්නේ මොකද්ද? ඒගොල්ලෝ අහන්නේ the signs of delta G, delta H and delta S at 298 Kelvin. 298 වල තමයි අහන්නේ. So 298 කියන්නේ low temperature එක. 298 කියන්නේ low temperature එක. Low temperature එක. Low temperature වලදී spontaneous නිසා මේක තමයි low temperature වලදී acceptable වෙන්නේ. Right? 298 වල low temperature එක. Is spontaneous. Low temperature spontaneous, right? එහෙනම් වල signs එක වෙන්නේ delta H minus, delta S minus and delta G is also minus at 298 Kelvin. They are referring to 298, right? Questioning hand 298 again. එහෙනම් all the signs should come up as negative values. So delta G is negative, delta H is negative as well as delta S is negative at 298 Kelvin. All the delta H, delta S and delta G are negative at 298 Kelvin. So the answer is answer number 2. So the answer is answer number 2. හරි පැහැදිලි නෙමෙයි. හරි මොකද delta G के sign එක temperature dependent වෙන්න නම් first thing you see that the sign of delta G is temperature dependent, right? Low temperature sign is negative, delta G sign is negative. High temperature the delta G sign is positive, right? So temperature delta G sign is temperature dependent. For that to happen, these two values should have two opposite signs. මේ values දෙකත් එක්ක opposite signs තියෙන්න ඕන නැත්නම් delta G के sign එක temperature dependent වෙන්න බෑ, right? ඒ නිසා signs දෙක opposite වෙන්න ඕන. හරි. එහෙම වෙද්දී ඒගොල්ලෝ කියනවා higher temperatures වලදී මේ reaction එක non spontaneous කියලා. ඒ කියන්නේ higher temperatures වලදී කොහොමද effect වෙන්නේ? value එක affect වෙන්නේ මේ sign එකත් එක්ක. මෙතන තියෙන sign එකත් එක්ක. high temperatures වලදී, right? non spontaneous නම් මෙතන තියෙන sign එක positive වෙන්න ඕන. right? එහෙනම් මේ sign එක negative වෙන්න ඕන. opposite signs තියෙන්න ඕන කලින් කිව්වා. එහෙනම් for this sign to be positive, the sign of delta S should be negative. Negative into negative will give you a positive sign, right? That is how the signs of delta G, the delta H, delta S are decided. And then they are asking the situation at the 298 Kelvin. So at the 298 Kelvin, as the reaction is spontaneous, the sign of delta G should also be negative. So all the delta H, delta S and delta G coming up as negative values, right? That is ready for the question number 21, right? Okay. Let's discuss about the question number 22. ආශ්‍රිතව ලියා ගන්න අපි question 20 වලට. Right. (22) See what it says. Standard Gibbs energy change for the reaction MO solid goes to M solid and half of O2 gas are at two different temperatures are given below, right? So they have given you a reaction like this. MO solid changes to M solid plus half of O2 gas, right? So temperatures and delta G values are given, right? Two temperatures and delta G values are given, right? Temperatures in Kelvin 1000 and 2000 and delta G values are given in kilojoules per mole. Minus 100.2 and minus 148.6. What they are asking is the standard entropy change of the reaction. What they are asking is the right. So asking data is actually delta H is not R of the reaction. That is what they are asking. Right now. So let's try to solve this one. So two temperatures and two values of delta G are given. So we can apply these things to the delta G equation. So we know delta G is equal to delta H minus T delta S, right? Or one can say delta H minus T delta S is equal to delta G. I'll take it like this. So it is better to solve the one, right? Not values, right? As not values are given. So let's apply these values to this equation. Right, you can come up with two equations. You can come up with two equations with these two, right? So applying at 1000 Kelvin, it will give you can take this one as delta H naught minus the 1000 Kelvin, 1000 delta S naught is equal to this delta G's value minus 100.2. This is equation 1. Then applying at 2000 Kelvin, delta H naught minus 2000, the Kelvin temperature is 2000, delta S naught is equal to minus 148.6. Is applying the two delta G values at the 1000 and 200 Kelvin, right? We assume that delta H and delta S won't change the temperature. That assumption is normally taken, right? So we have two equations with two unknowns. Two unknowns are delta H and the delta S. Two unknowns are there with two equations, so that we need to solve for these unknowns, right? So two equations are enough to solve for the two unknowns. The unknowns they solve for an equation they are right? Let's come up with some simultaneous equation solving, right? So if you are to take the 2 minus 1, this delta H will cancel off. If you take the 2 minus 1 or the 1 minus 2, let's take the 1 minus 2. At 1 minus 2, if you take the 1 minus 2, right, delta H will cancel off, right? So 1 minus 2, 1 minus 2 means you have 1000 delta S minus 2000 delta S. the 1 minus 2, right? That's equal to, you have minus 100.2 minus 148.6, 1 minus 2. So minus minus becomes positive, so that this is going to be 1000 plus 2000. So that is going to be minus 1000 plus 2000, that is going to be 1000 delta S naught, right? This minus 1000 delta S naught plus 2000 delta S naught. So plus 2000 minus 1000, that is 1000 delta S naught, is equal to, here you have plus minus minus plus 1, plus 148.6 minus this value. This is going to be, right, 48.4, no, 48.4, right? So delta S naught is then, so this is coming under as kilojoules mole, right? Kilojoules mole, right? These values are represented in kilojoules mole, right? So some thousand comes to the other side. So 48.4 into 10 to the power minus 3 kilojoules mole, right? So 10 to the power minus 3 and kilo, those things will cancel off, right? K means the 10 to the power 3, 10 to the power 3. So 10 to the power minus 3 is there, K means 10 to the power 3. Those two things will cancel off. That will give you 48.4 joules per Kelvin per mole. Sorry, joules per, you have the Kelvin as well, no? 1000 Kelvin, right? No? So these are values are coming with Kelvins, no? These are Kelvins, right? So joules per Kelvin per mole, right? No? Right? You have per Kelvin value, right? There Kelvin එකක් තියෙනවා නම පැහැදිලිද? And these values are coming up as Kelvins, no? Minus 1000 Kelvin, no? 2000 Kelvin. Temperature is substituted in Kelvin, right? That Kelvin comes to the other side as per Kelvin. Right? So 48.4 joules per Kelvin per mole. Such answer is there at the answer number 5. So your answer is answer number 5. Right now. Now මෙතන values ටික ඉන්නේ kilojoules per mole වලින්. මේ values ඉන්නේ Kelvin වලින්. Right now. So do the work in there. The question number 22. හරිනේ ළම. අපි යමු ඊළඟ ගේස් එකට. Right, let's do the question number 23. Right, question number 23. See what it says. Okay, this is going to be a ABCD question. See, if an endothermic reaction occurs spontaneously at constant temperature and pressure, then okay. So this is about the endothermic reaction. Endothermic reaction occurs spontaneously. Right? So endothermic reaction means we are thinking of a reaction with delta H positive. Endothermic. Spontaneously means we are discussing about a reaction which is it delta G negative. Spontaneous reaction. Right now? Okay, let's see. And pressure, then what they are asking. See what we can comment on this thing. Enthalpy is positive. Enthalpy change is positive means when going from reactant to products, when going from reactants to products, your enthalpy is increasing. Enthalpy increases. That idea is clear now, either. Delta H positive means enthalpy increases. Some delta property positive means that property increases when going from reactant to products. If some delta property is negative, that means that property decreases when going from reactant to products. That idea was discussed, right? So if delta X is positive means that X increases when going from reactant products. That is the idea. Delta X positive කියන්නේ X කියන එක නා increase වෙනවා කියන්නේ. Right? Delta X negative කියන්නේ X කියන එක නා decrease වෙනවා කියන්නේ. Right? Here delta H is positive means the H increases. H can enthalpy increases when going from reactant products. Right now? Okay. They are referring to enthalpy and the entropy, right? They are referring to enthalpy and entropy. Referring to enthalpy and entropy. Right? With this point, with both these points, we can come up with the sign of delta S. So delta H minus T delta S is delta G. You are having a positive sign for this one. And this guy is negative. That guy is negative. Right? To have a negative sign here with a positive sign appearing at the delta H, definitely the sign of this multiplication should be negative. If only the sign here, if only the sign here is negative, you can come up with a negative sign here. By adding a negative sign only to a positive sign, you can come up with a negative sign here. හරිනේද? මෙතන පොසිටිව් වුණොත් කවදාවත් මෙයා නෙගටිව් වෙන්න බෑනලා. මෙයා නෙගටිව් වෙන්න අනිවාර්යෙන් මෙතන සයින් එක නෙගටිව් වෙන්න ඕන. Right? For this sign to become negative, this should be positive. When opposite signs are multiplied, you get the negative value. Right? So delta S should be positive. So delta S should be positive. So delta S should be positive. So delta S positive means what? Delta S positive means when going from reactant products, S increases. Delta S positive means S increases. Right? When going from reactants to products, entropy is increases. Entropy increases. Right? The idea is clear, no? Right? So delta S positive means S increases. So enthalpy and entropy both increases going from reactant products. Do we have such an answer? Yes, with the 23rd question. So statement A says enthalpy of the system decreases, that is false. So A is false. So B, entropy of the system increases. Yes, entropy increases, that is true. C, enthalpy of the system increases. Yes, enthalpy increases, that is true. D is entropy of the system does not change. No, it change. Entropy of the system does change and will increase. So this is false. So B and C are true. That means answer is answer number 2. Answer is answer number 2. ABCD question. If A and B are true, answer 1. B and C are true, answer number 2. Right now? Okay, that is the answer for the 23rd question. Answer number 2. Alright. Okay. The clear. හරි අපි යමු ඊළඟ question එකට. Question number 24. Right? Let's do the question number 24. Right. 24th question. See what it says. Right. The enthalpy changes of vaporization and the entropy change of vaporization of liquid are given. The boiling point of the liquid. So what they have given? The enthalpy change of vaporization. So they have given the delta H naught vac is given as 45 kilojoules per mole. Right? And the entropy change of vaporization is also given. Vac. Not the standard values, just some values are given as 90 joules per Kelvin per mole. Right? No? They are asking us the boiling point of the liquid. Right? They are asking us the boiling point. Right? So answers are given in Celsius. Answers are given in Celsius. Right? What is the task here? So boiling point. So boiling point means what? Boiling point is the temperature at which a liquid converts to gas. So it's a temperature of a phase change. Temperature of a phase change. So it's a equilibrium. It's a equilibrium situation. Right? This kind of phase change happens here. Liquid phase convert into the gas phase. Phase change. So phase changes means those represent equilibrium systems. Phase changes happens with equilibrium systems. That means delta G is going to be 0 there. Delta G is going to be 0 there. Equilibrium systems. So we can apply this thing. So delta H minus T delta S is equal to 0. That is the delta G. No? So if you are to subject the T, the temperature at which this phase change occurs, it is going to be this delta H comes to that side and divided by delta S. This is the temperature of the phase change. So this is the boiling point. This is the boiling point. Temperature at the phase change. Here it is about the boiling point. Right? So apply the values here. So delta H value is the 45 kilojoules mole. So Lama, this is all about vaporization, right? Vaporization process is this, right? Vaporization means liquid convert into gas, right? The vaporization process, right? So delta H and the delta S values are also given for the vaporization, right? So we can come up with the boiling point then with the use of those values, right? So if you are regarding this one as boiling point, right? If you are to think of this one as boiling point, then these values should be the vaporization values, right? Now, okay, let's substitute the values. So this value is 45 kilojoules mole, 45 kilojoules mole. Both the values should come with the same dimensions, right? So this should be applied in kilojoules, right? So 90 into 10 to the power minus 3 kilojoules per Kelvin per mole. I have just converted this value to the kilojoules, right? 92 power 3 dividing that thing, right? So kilojoules stuff will cancel off. The mole value is also cancel off, and this is 1, this is 2, and this 3 to the power minus 3 comes to the top as 1000. So that is going to be 1000 divided by 2 Kelvin. This per Kelvin comes as Kelvin. So 500 Kelvin. 500 Kelvin. In Celsius, you have to deduct some 273 from this. You have to deduct some 273 from this. That means it is 227 Celsius. 227 Celsius. Right? Do we have such answer? Yes, that is answer number 5. This is answer number 5. Right? So answer is answer number 5. Right now? So things are clear. Just do the working. හරි නේද? Let's discuss the next question. Question 25. Right. Question number 25. See what it says. So, which of the following reaction steps is not present in the Born-Haber cycle of NaCl solid? This is regarding the Born-Haber cycle of NaCl. This is regarding the Born-Haber cycle of NaCl, right? Okay. So they are asking that which is not present in the Born-Haber cycle. Which is not present in the Born-Haber cycle, right? So let's come up with the answers here. So I'll draw the Born-Haber cycle, and then after that let's see, right, which are not present there, right? So very clear, the answer is also number 1. So in a Born-Haber cycles, the aqueous solutions are not there, right? That is very clear. The answer is answer number 1, right? So if you are forgetting about the Born-Haber cycles, right, let's quickly go to the cycle of the NaCl, right? So anyway, with the Born-Haber cycles, you are not coming with the aqueous states, aqueous solutions. So basically, the answer is answer number 1, right? Okay, so let's draw the Born-Haber cycle of NaCl, right? So if you draw the Born-Haber cycle of NaCl, you have to start with the reference forms of constituent elements there. So that means the reference forms are Na solid, sodium comes as monoatomic solid, and chlorine's reference form is Cl2 gas. So as we should have only just one chlorine with this system, it should be half of CO2 gas, right? This is the reference form. And you should have the solid ionic lattice at here. This is the delta H naught formation. And then you have to have the lattice energy here. That is formation, right? So lattice energy means forming the solid ionic lattice starting from the constituent gaseous ions like this, right? Then we are to connect this state to this state. So to come up with Na plus gas as well as Cl minus gas, you have to do some ionization enthalpies as well as electron gain enthalpies. To produce Na plus gas, you have to ionize the sodium, right? You have to do some ionization enthalpy to the sodium gas, right? So to come up with Cl minus gas, you definitely need to do the electron gain enthalpy to Cl gas, right? So for the ionization as well as for the electron gains, first you need to come up with the monoatomic gaseous form. Come up with the monoatomic gaseous form, right? So let's try to come up with the monoatomic gaseous form from these reference forms, right? So sodium can be converted to its monoatomic gaseous form by a few ways, right? So you can think of sublimation of sodium to come up with sodium gas. This can be done by kind of sublimation, or this can be done by kind of atomization. Reference form converted into monoatomic gaseous form, right? And half of Cl2 still appears. Now you can convert this guy to the Na plus gas by applying the first ionization enthalpy. Half of Cl2 gas still appears. This is the first ionization enthalpy. Then we have to come up with the monoatomic gaseous form of chlorine as well, to do the electron gain for the chlorine to come up as Cl minus gas. So that can be done actually by applying a bond dissociation to Cl2 gas, or by doing some atomization for the Cl2 gas, right? The reference form converted into, right, the monoatomic gaseous form, right? These guys appear as they are, and this conversion to Cl gas, this conversion of half of Cl2 gas to Cl gas can be done by applying the atomization once. So you are supposed to produce 1 mole of gaseous atoms, so atomization, right, once is enough. Or you have to break half of Cl bonds, half of Cl bonds, half of Cl bonds. If you have to break half of Cl bonds, you can come up with 1 of Cl gas, right? So atomization O, you can come up with half of delta H naught bond dissociation, right? That will give you the Cl gas, and that Cl gas can be converted to Cl minus gas by absorbing this electron, right? That can be done by doing the first electron gain. So these are the enthalpy terms appearing in the Born-Haber cycle of, right, NaCl. The thing is clear. So if you have to apply the Hayes' law, that delta H naught F, this thing will be equal to all of these stuff, right? So you can apply this stuff, right? It is not needed in this question, but just for the completion of what we had done, I just write, right? Okay, so this is the Born-Haber cycle concept for the NaCl. So let's go to the right choices here. They are looking for the step which is not present there. So that is definitely the step number one, the choice one indicated there, right? Aqueous forms are not available here. Other things are okay, no? NO solid converts to yeah. This can be done even by sublimation, as well as you can do the fusion and vaporization. You can do some fusion from here, and then you can come up with vaporization, right? That can be done by that as well, right? So you can convert this into liquid and then liquid to gas, right? Such kind of scenario also can be done, right? Or we can come up with delta naught, right? Fusion plus vaporization. That also give you the right sodium gas, right? So the Roman number, the second choice is that, right? That is kind of a fusion have been done. That is okay. So Cl2 gas convert to 2 of Cl gas, right? That's in that into half. That into half is used in this case. So that is also can be acceptable. That can be term, right? Then Cl gas accepting an electron, that is electron gain. That is also there. And finally, the fifth one is the lattice enthalpy, right? Lattice formation enthalpy, that is also there. This thing, right? This is the right choice number 5 appearing, and here you have the choice number 2 with the fusion, and choice number 3 appears here, half of this thing. Choice number 4 is this one, right? Electron gain. So 1 is the one which is not there, right? So the answer is answer number 1, which is not appearing, right? Aqueous solutions are not there in Born-Haber cycles. Aqueous components are not appearing, right now. So the answer is clear, no? So answer is answer number 4 for the question number 25, right? Okay, let's complete this stuff. Right now, let's do the question number 26 day. Right? Question number 26. Right. 26th question. See what it looks like. It says at a given pressure, Right, this is about the first statement, second statement question, no? Right. Statement 1. Let's copy statement 1 first of all. What it says. At a given pressure, the spontaneity of the reaction between N2 and H2 to give NH3 drops with increase in temperature. Right? The given pressure, the spontaneity of the reaction between N2 and H2 to give NH3 drops with increase in temperature. Right. So let's discuss about this thing. So this is about this reaction. Right? N2 gas reacting with H2 gas to form the NH3 gas. So this is kind of formation enthalpy for the NH3. This kind of formation enthalpy of the NH3, right? So you can write it like this, right? So Lamine, there's one thing you should know to answer this question properly. So the point is, so if you are regarding to stable compounds, if you are thinking of stable compounds, for stable compounds, Lamine, their formation enthalpies are negative. Remember that. There is one, right, a major point you have to grab from this question, right? For the stable compounds like H2O, H2O liquid, NH3 gas, right? For the stable compounds at room conditions, at considering conditions, normally at room conditions, for the stable compounds, they are delta H naught F values are negative, right? Right? Keep that in mind, right? This is one point you have to note from here, right? So I'll write it like this. For stable compounds at room conditions, right? They are delta H naught F, the formation enthalpy values are negative. So starting from the reference forms, forming these stable compounds will decrease the energy. So a compound is stable means it is with low energy. Lower your energy, that means you become more stable. So for the stable compounds, right, their enthalpy values are lesser compared to the reference forms. That is why the reference forms are connected to form those stable compounds. Reference forms are the most abundant forms of elements. No? Those will be connected with each other to form a compound, right, when they are stable. Right, so that means their formation enthalpy should come up as negative values. The energy should decrease than the reference forms. That means their formation enthalpy should be negative, right? That idea should be there to answer this question, right? Okay, keep that in mind. This is important stuff to remember, right? Okay, so what they are saying, at given pressure, the spontaneity of the reaction between N2 and H2 given H3 drops with increase in temperature. That is what it says. Okay, so right, if you think of delta G stuff, right? So delta G stuff. So delta H F is negative. What about the entropy change here? Entropy change here. So going from reactant products, number of gas molecules, what happens? You have half, you have 1.5, that means altogether two gas molecules at this side, just one gas molecule at here. Number of gas molecules 2 here. I mean half and 1.5 is 2 here, but here just 1. So going from reactant to products, number of gas molecules decrease. Decrease when going from going from reactants to products. That means entropy decreases. Number of gas molecules decrease means entropy decreases. That means the sign of delta is negative. Sign of delta is negative. Right? For this reaction, the sign of delta is negative. Sign of delta H is negative. So let's apply those things to your delta G expression. This is negative as well as this. So that this is positive. So delta G could be negative or positive. According to temperature, that depends. According to temperature, that depends. Right? What they are saying, again go to the question. At a given pressure, the spontaneity of the reaction between N2 and H2 gives H2 drops with the increase in temperature. What happens with the increase in temperature? When temperature increases, positive energy increases. Positive energy increases. So when temperature increases, delta G becomes more positive. So with the increase in temperature, spontaneity decreases. Spontaneity decreases. Right? With increasing temperature, spontaneity decrease. Spontaneity decrease. Increase in the positive nature means spontaneity decrease. So the statement is true. Statement is true. So the statement is true. So the statement is true. The spontaneous of the reaction decreases with increase in temperature, as the sign of delta S is negative. Right? Ne? Okay. Let's copy the second statement. Statement 2. What it says? They're saying entropy change of the reaction between N2 and H2 to give NH3 is negative. That is true, no? From this one, it gives a reason for statement 2. Statement 2 is true. Statement 2 is true. So statement 1 is true. Statement 2 is true. Both are true, and it is the reason, right? The statement 2 is the reason for delta G to become positive when the temperature increases. As sign of delta S is negative, that is why delta G becomes positive when the temperature is increased. So statement 2 explains the reason for the statement 1. So answer is answer number 1. Answer is answer number 1. Answer is answer number 1. Right නේද? delta S के sign එක negative නිසා තමයි temperature එක වැඩි කරද්දී මේ whole process එකේ positive nature එක වැඩි වෙන්නේ. delta sign එක negative නිසා තමයි මේ sign එක positive වෙන්නේ. ඒක නිසා temperature වැඩි කරද්දී positive nature එක වැඩි වෙලා delta G positive වෙන්නේ. Reaction is non-spontaneous vein because of the sign of the delta S is negative. So the second statement explains the reason for the first statement. So answer is answer number 1. Right? This is the review for the Question number 26. Right, Nila? හරි. අපි යමු ඊළඟ question එකට. Let's go towards the question number 27. The final question under the past paper part. Under past paper MCQs, now we are going to discuss about the last question appearing in our table, right? Question number 27. Right. Question 27. See what it says. So that is again a first statement, second statement question. Let's discuss about the statement one. First statement. See, a spontaneous reaction always has a negative Gibbs energy change, no matter what the conditions are. That is false, no? That is false. That is false. Last day also we had discussed about this scenario, right? So the comment is actually the sign of delta G can be used to predict the spontaneity of the reaction, right? Only if the reaction or the change has been done keeping the temperature and pressure constant. Only if the reaction has been done keeping the temperature and pressure constant, then only we can use the sign of delta G to predict the spontaneity. If not, you can't. If not, you can't. So they are saying a spontaneous reaction always has a negative. Always has a negative Gibbs energy. That is false. Not always. Only if that process is done as a constant temperature, constant pressure process, then those guys are with negative Gibbs free energies. Only if the spontaneous process is done at constant temperature and pressure, then only we can say that delta G value is negative, right? If not, we can't comment. We don't know. Last day also we had discussed about that same scenario. Let's go to the reviews of the last day's section, right? I have given a different example as well for that thing. We have discussed that thing, right, again and again with the last day's lesson, right? So let's go to that. So remember that this is the short review, right? Only if the change has been done at constant temperature and pressure, we can comment on the spontaneous reaction by considering the sign of delta G. If that change is not done in a constant temperature and constant pressure situation, then we can't predict the spontaneity by merely looking at the sign of delta G. Right? That idea should be with you. Right? Okay. So that is the idea. Right? So that as the statement says, statement comes up with that term always. We have, as we are with some exceptions, the statement has to be considered as false. Right? Statement එකේ always කියලා තියෙන නිසා හරි අපිට statement එක false කියලා ගන්න වෙනවා. Always කියලා තිබ්බේ නැත්නම් as a general statement we could be able to consider it as true statement, but they are saying always. Then we have to take that as a false statement because exceptions appears when appears with the processes which are done without keeping the temperature and pressure constant. Right? That is the idea here. Right? So statement 2 now. See what this is. Gibbs energy change can be used to predict the direction of the reaction only under constant temperature and constant pressure. Yes, this is what it says. This is what it says. It is true. This is true. Right? Only if the change has been done keeping the temperature and pressure constant, you can use the sign of the delta G to predict the spontaneous reaction. Right? Okay. The same point says that statement 2 is true. Right? 1 is false. Statement 2 is true. Right? See the above explanation. Same thing, right? Same explanation. Says that statement 2 is true. Right? No? Okay, so 1 is false, 2 is true. So that means answer is answer number 4. Ne? First statement false, second statement true. That means answer number 4. Right? No? That is the review for the question number 27. So complete that one.